Hi guys, so far we defined three types of friction: static friction and limiting friction and kinetic friction. And we define two coefficients. Suppose if we can write from the limiting friction, so F suffix S max, so this is known as limiting friction, which is directly proportional to normal action force. Now we define that F suffix S max, which is directly proportional to R, and we remove the proportionality symbol, which make it equal, and replace a constant mu suffix s times r. So here mu suffix s is known as coefficient of limiting friction. So the coefficient of limiting friction can be calculated by dividing the static friction maximum upon normal reaction force. But there is another way to calculate the coefficient of static friction. So for that we need to take little trigonometry help, but it is very easy to calculate. Suppose, just imagine, so this is a block of mass m which is kept on a table. So if I draw the forces, so this is a downward force, so the weight mg, which is acting downward force, is exactly counterbalances by the opposing force, which is called as normal reaction force R. We are representing R as a normal reaction force. And if this is a force which is applied, so I can write here this is applied force. Applied force, let it be P. Let P is the applied force. So on the applied force opposite exactly, there is a friction force which will act. Right now if I take this friction is a static friction F suffix max. The friction force right at here I considered as static friction. Now if you can see, the applied force is opposite to the F suffix x max. Now these two forces, R and F suffix s max, these two forces are acting in this plane. Suppose if you find the resultant of these two forces, I will draw the two forces separately. The resultant of the two forces, one is R, which is acting on the block, and another one is, if I take only the static friction force, sorry, it's a limiting friction force. So this is Fs max, limiting friction force. So these two forces are vectors, we can add them vectorially. Suppose if this is a vector and this is a b vector, if we can add a to the b vector, what we can do that? So we will take the b vector over the a vector. Now if I can add that vectorially, so I can take the b vector along in this direction. So this is the vector F suffix s max for addition only, and we can get the resultant vector. So this is the resultant vector of these two vectors. I can represent that with this color. So this is the resultant vector which represent in the black color. So the black vector is the resultant of, so this is a very important, this is the resultant of two vectors. One is R, another one is limiting friction vector F suffix S max. Now, if you can take this as a triangle representation, suppose let me take this as O, and this is point B, and this is point C. So this OB, and if I take this as a OB and AC are the parallel, and OA and the CB are also parallel. Now if I take this an angle theta, so write it here, the angle theta from right triangle, from figure O, this is B and C. From right triangle OBC, you can write tan theta. Tan theta equal to BC upon perpendicular upon base OB. So from the figure, if you can see, the BC is nothing but the side, the BC is nothing but Fs max, it is the limiting friction, and OB is nothing but R itself, so it is a normal reaction force R. So now we got it, tan theta equal to Fs max upon R, and we know that this value Fs max upon R we call as mu s. Therefore tan theta equal to mu suffix s. So here the coefficient of static friction is converted into certain angle. The coefficient of static friction is converted into certain angle, so that angle which is made with the normal reaction force. So tan theta equal to mu s, that is the coefficient of static friction is equal to the tangent of the theta. So here theta we define as a new definition. Here theta we define as angle of friction. Theta we define as angle of friction. So what is this angle of friction definition? How we define angle of friction? So the angle of friction, it is defined as the angle between the resultant of the limiting friction and the normal reaction. Which makes with the normal reaction. It is an angle. So angle of friction, it is just an angle. So this is angle between the resultant of, so this is very important, the resultant vector of the limiting friction and normal reaction, and that angle made with the normal reaction. So here the theta we define as angle of friction. So if you can fill the diagram at here, so if you can take a green color, if you can draw, so this is the resultant vector. So this is the resultant vector of limiting friction and normal reaction. The resultant vector making an angle theta with the normal reaction. So this theta only we define as angle of friction. Now the tangent of angle of friction, tan theta, the tangent of angle of friction is equal to coefficient of static friction. Now we got two formulas for the coefficient of static friction. So the first formula equal to mu suffix s equal to Fs max upon R. It is also equal to, it is the limiting friction upon normal reaction. So that is the first formula for the mu s. With respect to angle, mu s equal to tan theta. So here the theta is the angle between the resultant of limiting friction to the normal reaction with respect to normal reaction. So this theta is called as angle of friction. So this angle of friction very useful to do further simplification. So these two terms are equal. Tan theta equal to mu s.